Students, this video is about high advanced level of height and distance questions. So there will be many topics which you have done in your class 9-10, but this height and distance questions will be a little bit tough. Okay, I know about these angles are equal. You must be knowing that if something like this, the sum of is 180. So I will not be focusing on this. But I will give you a basic formula which helped me in my studies a lot. So that's a special ingredient formula. If this angle is alpha, this angle is beta, and if this angle is A, this angle is B, this is ABC and this is D, so this is theta. This is N, this is N. If something like this happens, so we can write it as m plus n into cot theta equal to m cot alpha minus n cot beta, and m plus n to cot theta equal to cot B. So this is called M minus n theorem. A really useful one in order to solve the questions of height and distance. Okay, let's start with some tough questions. Okay, let's start with the very first question of the day. So here they have given from the bottom of a pole of height h. Question is, and the height is h. Okay, so let me draw it first. Second thing is the angle of elevation of the top of a tower is alpha. It's like this. So this is our tower. The pole subtends an angle beta at the top of the tower. This one. So find the height of the tower. That's it. No numerical value is given. So we have to find the height of the tower. So let the tower be PQ. Let this be OA. Let this distance be x. So this is alpha minus beta. So this is simply 90 minus alpha. That's it. So PQ equal to tower, OA equal to pole. So we can write it as tan alpha equal to PQ by OP, that is PQ by x. That's it. So we can write PQ equal to x tan alpha. Okay, so H plus QR. So H equal to H plus QR. Okay, this one is H. So H plus QR. This is R. Okay, H plus QR equal to x tan alpha. So similarly, you can find QR. It is x tan alpha minus H. So in triangle APQ, that is APQ. This. So we can do that, the tan So AQR triangle is tan alpha minus beta equal to QR by X. And after that we can put the value QR value as X tan alpha minus H. So this is a trick of this kind of chapters where you have to be very focused about the pattern now to get you to your desired answer. So this is tan of alpha minus beta. So similarly X equal to the reverse. So it is tan alpha. So this is the pattern of solving this kind of a question. Now the second question is vertical pole shadows and how the shadows are changing. Remember that if this is the tower and you are here and you're here and you're here, and if you're proceeding like this, then the angle of elevation like this it keeps on increasing. It's like this. So if you are seeing the Paris Eiffel Tower from a long distance, okay, this is your Eiffel Tower, and see it for a long distance, you don't have to stoop so much. But if you want to see it from this, the angle of watching is too high. So remember that towards the pole or tower, higher than this one is a very important trick. Okay. Now they have given the length of the shadows of a vertical pole of height h. So this is h. Thrown by the sun's rays at three different moments are h, 2h and 3h. So the shadows are increasing. This and this. So this must be h, this must be h and this must be h. So that makes it 2h, that makes it 3h. So 3 same. So they asked us to find the sum of the angles of elevation of the rays at these three moments. So if you just call it theta 1, theta 2 and theta 3, so we need to find the sum of these three. So this one A is indeed a very interesting question. I haven't seen like this before. It's a new question. Okay, so let's solve it. So OA with the vertical pole and OP1, OP2 and OP3 is the three different lengths of the shadows. So what happens in angle, there are three triangles are created actually, AOP1, AOP2 and AOP3. So in AOP1 we can write, do it with tan theta. OA by OP1, that is h by h. So this one is 1. So here we can get theta equal to pi by 4 very easily. In triangle AOP2 we get tan theta 2, so that is OA by OP2. So this is h by 2h, it's half. So theta equal to tan inverse half. In AOP3 is tan theta 3, that is OA by OP3. So that is h by 3. So similarly you can write it as tan inverse 1/3. So that is directly you can write it. So we just leave this part. So now you have to just find these three angles. The first part is pi by 4, 45 itself, and tan inverse half plus tan inverse 1/3. That has a formula tan inverse a plus b by 1 minus ab. If we do it like this, this will become tan inverse 1, that is pi by 4 itself. So answer is pi by 2. So it will create a 90-degree angle. So after this, there is a bumper sum now. This question says three vertical poles of height h1, h2, h3 at the vertices ABC subtended. Okay, so this is the first part, A, B, C. So there are vertical poles and pole heights are H1, H2, H3 at the vertices A, B, C. So let the first pole be this, let the second pole be this, and let the third pole be like this. Okay, so this is our H1, let it be AP1, this is H2, this is BP2, and H3, that is CP3. After that, three vertical poles at the end of the vertices ABC of angle ABC subtended at alpha, beta and gamma respectively. Okay, so subtended angles. So here beta gamma respectively at the circumcenter of the circle. So subtended at the circumcenter of the circle. So that is be O. So from O, if we add this and this, so this angle will be alpha. That's the concept they have given. So if we add this and this, so this angle is B gamma, and we add this with this, so this angle will be beta. Bit complicated diagram to draw, but not that much tough once it is being drawn. Okay, now our target is to find out what. So they have said if chord alpha, chord beta and chord gamma are in AP, then H1, H2, H3 will be in what? So in all perspective, it's a really complicated question. So here the circumradius of the circle this. So in triangle OAP1, we will start. As usual, like every sum, I will be doing it with respect to tan. So tan alpha equal to AP1 by OA. So here we can write H1 by R. So simply H1 equal to R chord alpha. We are going to do everything with respect to chord here. And similarly H2 equal to R chord gamma. Sorry, R chord beta, and H3 equal to R chord gamma. That's it. So it is given that they are in AP, so we can write it that 2 chord beta equal to chord alpha plus chord gamma. So just putting the value 2R chord beta equal to R chord alpha plus R chord gamma. So similarly 2H2 equal to H1 plus H3. So by this we can say that H1, H2 and H3 are in arithmetic progression. That's it. So in the next video I will solve some more problems on height and distance.